Hi, welcome back. At the end of this video, you should be able to A. Use the basic rules of differentiation. Basic rules of differentiation. The derivative of a constant. If k is a real number, the derivative of fx equals to k is f prime x equals to 0. Example 4. Find the derivative of the following function. Now we know that if fx equals to k, where k is the constant, f prime x equals to 0. A. Fx equals to ln 8. Ln 8 is a constant. Therefore, f prime x equals to 0. B. Fx equals to 0.73. Therefore, f prime x equals to 0. C. Fx equals to 3. Therefore, f prime x equals to 0. D. Fx equals to 2e. Therefore, f prime x equals to 0. The derivative of a function of the form x power of n. If k is a real number, then derivative of fx equals to x power of n is f prime x equals to n x power of n minus 1. Example 5. Find the derivative of the following function. Now we know that if fx equals to x power of n, thus f prime x equals to n x power of n minus 1. A. Fx equals to x power of 5. Therefore, f prime x equals to 5x power of 4. B. Fx equals to 1 over x squared. So we need to change their form. Becomes x power of negative 2. So if we differentiate the function f prime x equals to negative 2x power of negative 3. For the final answer, make sure we write the power must be always positive. So therefore, we change its form. So becomes negative 2 over x power of 3. C. Fx equals to x, where equals to x power of 1 over 2. So f prime x equals to 1 over 2 x power of negative 1 over 2. So for the final answer, we change its form. So becomes 1 over 2 third x. D. Fx equals to 1 over third x equals to x power of negative 1 over 2. We differentiate it. So becomes negative 1 over 2 x power of negative 3 over 2. So we change its form. Becomes negative 1 over 2 x power of 3 over 2. The derivative of a function of the form kx power of n. If k is a real number, the derivative of fx equals to kx power of n is f prime x equals to nk x power of n minus 1. Example 6. Find the derivative of the following function. Now we know that if fx equals to kx power of n, thus f prime x equals to nkx power of n minus 1. A. Fx equals to 5x. Therefore, f prime x equals to 5. B. Fx equals to 3x squared. Therefore, f prime x equals to 6x. Why 6x? This because the power we multiply by the constant 3 and then x power of power we must minus 1. C. Fx equals to negative x power of 12. Therefore, f prime x equals to negative 12x power of 11. D. Fx equals to 2 pi x cubed. Therefore, f prime x equals to 6 pi x squared. E. Gx equals to 5x power of 4 over 3. Therefore, g prime x equals to 20x cubed over 3. F. Hx equals to 12 over third x. So, we modified that function, becomes 12x power of negative 1 over 2. Differentiate hx becomes h prime x equals to negative 6x power of negative 3 over 2. Remember, we need to change. Make sure the power of x must be always positive. Therefore, it becomes negative 6 over x power of 3 over 2. End of the basic rules of differentiation.